ఓకే అండి. సో ఓకే అండి. గుడ్ ఈవినింగ్ ఎవరీవన్. Today classes in Java. Let me repeat it. What has been happened yesterday? The process of declaring the class inside the class is known as inner class, or you can say nested class also. Part of class, already you are declaring variables, methods, blocks, constructors. The same way, we can declare one class inside the class. By terminology, you can say inner class or nested class. Member inner classes. There is one term known as member inner classes. The inner classes which are declared as members of class, like variable, member of class, method, member of class, constructor, member of class. The same way, one inner class also member of one class. We can say member of member inner classes. You can say these member inner classes are categorized into two types: static member inner classes and non-static member inner classes. The member inner classes which are declared with static keyword are known as static member inner classes, or you can say class member inner classes, you can say. Now let me start explaining this concept with a diagram. Already program is there. So I'll be reading the rules. I'll be drawing the diagram. I'll be explaining that program also, what I written to you. Okay, right. Today we are concentrating on two diagrams, no? Right. One is static member inner class. One is instance member inner class majorly. Yesterday I updated the notes, no? Already? Right. Okay. Now look here. So we are drawing our old diagram: method area, heap area, Java stack area, and so on. Now, method area where classes are loaded, heap area where objects are created, Java stack area where methods are executed. Here, before starting it, here, execution flow of static member inner class. Execution flow of static member inner class. If I have one member inner class declared with a static keyword, what happens? You're going to observe it. So I want to know the class files generated for it. Class files generated. I want to know how many class files generated. So let me open yesterday's program. Right. See there. Inner classes application 1 anyway. Now, some people will be there who waste the time. Because of that, we must not waste our time. That's very important because I never speak. Observed or not? Have you observed? If anybody on the video also, I'll close it. I will not ask particular person, close it, wasting my time unnecessarily. We don't have that much of time, no, in career part, right? Okay, look here. Now, subclass 1. This is subclass 1. In this subclass 1, we declared one subclass 2. Okay, right. Now, there is one concept for compilation or compiler known as segmentation. One phase will be there. In the compilation process, many phases will be there. Among that, one phase is segmentation. Segment means meaningful partition. We call it as segment. According to object-oriented programming, segment means class. So class is one meaningful partition. Because of this reason, whenever you saved the program starting, multiple classes under one single program, but even separate dot class files came or not now. So why separate dot class files came means compiler separated them. That's called segmentation. The same way here. Now your compiler will identify this as one class, subclass 1. Inside that subclass 1, we had subclass 2. So compiler will take this subclass 2 outside. Now it is 2 classes, no? Subclass 1, subclass 2. Now compiler will say, these 2 are 2 meaningful partitions. Subclass 1, part of this subclass 1, I removed one subclass 2. This is a subpart of this I removed. For compilation, the code removed for compilation. That is one part. So it says that one is subclass 1 dot class file. One is subclass 2 dot class file. But the subclass 2 came outside the subclass 1, no? Right. So subclass 2 is the inner class. In Java, inner classes are represented by $. What is the symbol for inner class now? $. See there. Compiler will take that outer class as a subclass 1. From that subclass 1, it takes a subclass 2 and compiles. After compilation, it adds one $subclass 2. Meaning is this is one inner class. But the inner class of what class I must say no. So because of this reason, it adds subclass 1 $subclass 2. That's the concept. All of you understood this now. The meaning of that is subclass 2 is the inner class of subclass 1. If we take main class, no inner class concept, no, in the main class. So demo inner class 1. Demo inner class 1 dot class file. That is main class. Now let us see. The dot class files are 3 or not. Let me cross check. Here. Inner class application 1. Now bin here. Bin means dot class files. Under test, you can see here. Subclass 1 dot class file. Subclass 1 $ subclass 2 dot class file. Subclass 1 $ subclass 2 dot class file. Under M-access demo inner class 1. All of you understood that inner class dot class file, right? From today, $ in your Java represents inner class. Now see there. So total 3 dot class files are there. Now, first, which dot class file will come now? Sir, demo inner class will come first because it has one main method. Main method is loaded. Main method will come out. Main method will come for execution. Main method came for execution now. The main method first line is nothing but subclass 1 OB1 is equal to subclass 2. This is the first line. Now the first line is here. Subclass 1 OB1 is equal to new subclass 1. Now, so new subclass 1 means create object for subclass. That's the meaning actually. Now, subclass object is created. Subclass 1 object is created. I am creating object for subclass 1 object. So new operator is there, no? I created address. New followed by subclass 1. Now the subclass 1 must be loaded. Now subclass 1 is loaded for object creation. Subclass 1 is loaded. Subclass 1 is loaded. This is one outer class. This is one outer class. So what is the rules of your JVM now? Sir, while class loading, static members has to get the memory. While class loading, static members has to get the memory. That is a rule. So subclass 1, static members has to get the memory. Let us see. In the subclass 1, A. Statica, non-statica? Non-static. So, A, memory not available to you. A, memory not available. Now, B got the memory now. Static variable, B got the memory. Now, B is equal to 20. B got the memory. Understood this? Right. Now, A no memory, B got the memory. M1, memory available or not available? Not available. M1, no memory. Because non-static. For A memory not there, B memory is there. M1 memory not there in the class. Now, this class is statica, non-statica. Static has to get the memory within the class, no? That is the rule. So that only new thing here. Now, the static class will be loaded. That inner class also will be loaded. Will get the memory within the subclass 1. Now, B is getting the memory in subclass 1. The same way, dollar. So, dollar subclass 2. You have to get the memory here. This is inner class. This is static member inner class. Static member. Static member inner class. Now, anyway, the static got the memory, no? Right. Means loaded. When the static member inner, M2 is there, M22 is there. Now M2 is non-static, no memory. M2 for you memory not there. M22 you are static, so you'll get the memory. M22 got the memory. Void M22 got the memory. All of it clear with loading? Yes or no? Na? So static member inner class, interview purpose, remember? Static member inner class will get the memory within the outer class while outer class loading. While outer class loading only, so static member inner class will get the memory within the premises of outer class. That's the diagrammatical information. Once the loading has been completed, you are creating object for outer class or inner class. Here you are creating object for outer class or inner class? Outer class. So we are creating object for outer class. When we are creating object for outer class, the non-static members of outer class has to get the memory. So what are the non-static members now? A is non-static. M1 is non-static. So A will get the memory here. A will get the memory here. And M1 will get the memory. Void M1 will get the memory. Now A got the memory here. And M1 got the memory here. Here we had 1 and this is your outer class object. Outer class object holding the instance members of outer class. What are the instance members of outer class? Means A and M1. All of it clear? Right. Now the address what is available here. The address what is available here will be loaded to OB1. All of you understood this? Yes or no? Now? Right. Now call OB1.M1. OB1.M1. I am calling the method from here. M1 I am calling now. I am calling M1 method. This M1 method is coming for execution. Void M1. Get them. M1 came here. So the M1 execution starts here. M1 will display A and B. Now M1 can access A. M1 can access B. A. See there? This M1 came from this object. The control will go to this object to cross check A is available or not. A is available, no. Answer will come. This M1 came from this object to check the B, it gone here. B not available. The object came from this class. Control will come here and B will come. All of you understood this? Right. So M1 anyway, outer class method can access the variable from object, variable from class. So this is okay anyway. Now our target is what now? Sir, creating object for inner class. Whenever you want to create object for inner class here, see the syntax. Sir, create object for subclass 2, subclass 1 dot subclass 2, OB2 is equal to new subclass 1, subclass 1 dot subclass 2, you had it. So here subclass 1 dot subclass 2. The meaning of this is create object for subclass 2 which belongs to subclass 1. That's the concept. All of you got this point, right? Now see, create object for subclass 2 which belongs to subclass 1. So object creation starts. For outer class, inner class object creation starts. So we are creating object for subclass 2. Now, while object creation for subclass 2, what are the non-static members available in the object 2 now? Sorry, in the subclass 2. What are the instance members available? Only void M2. Yes or no? Are you observing? Right. We are creating object for subclass 2. The subclass 2 method is M2. This one will give it as a 5. Only one method, no? This is inner class object, only one method. This address will be loaded onto OB2 like this. Now, after this one, we are calling the method OB2 dot M2. A rule is there. Observe it. Now I'll open the nodes. Static member inner classes can be declared with both static and non-static members. The instance method, which is declared in static member inner classes, the instance method which is declared in static member inner classes will have behavior like static method, and can access only static members of outer class. This only, no? At last I am calling a method or not now? M2. The M2 method is an instance method actually, but it cannot access instance variable. Why? Let us see. Now I am calling this M2. That M2 method will come for execution. That M2 method is coming for execution. Void M2 method will come for execution. We are having a number as 7. 7. Like this. Now this M2 method trying to access A and B. Trying to access A and B. A is equal to 10 and B is equal to 20. Actually, that M2 method cannot access A. That only in our concept. A is instance variable actually. Outer class instance variable. Because of this reason, the variable available in the outer class method. Actually, I'm drawing a diagram actually. But actually in the real time, without diagram also idea should come. Sir, I'll draw the diagram. It will not give a time to you actually. Core Java trainer will have a time, will write. But actually experience meaning is he has to get the imagination immediately. So outer class instance variable will be available within the outer class object. That only know green color. A is available in the outer class object. M2 method belongs to inner class object. That's a blue color. Na? Now this method want to access the variable from another class, another object. But there is no link between the objects. There is no link between the objects. No. What is the rule of references? One object holds reference of another object. Then only the members of one object can use the members of another object. Here M2 want to access A. Not possible, no, sir. Because A is in another object and M2 is another object. Not possible, no, sir. Let us see how it is not possible. I am accessing A. Now M2 method came from this object. Control will come here. Wherever M2 is coming, the control will come there only. Example, my laptop charger, I forget it. Suppose I forget it. Laptop charger, I forget it. When I come here, my loader will take my bag and he'll open. Laptop charger not there. Then he'll ask me, sir, laptop charger not there. You came from which building? He'll ask. So just now I am coming from Nacker building, I came. So my loader will run to Nacker. In the Nacker building, not there. Then he'll call me and ask, sir, here also not available. Before Nacker, you came from where? I'll say one location. 2 p.m. my class will run in that building, that corner building. So my loader will run there. The meaning is, from where you are coming, control will go there. That only concept. Here M2 is coming from where now? From this object, control will go to this object. So in this object, A not there, no? Right. Whenever A not there, now this object belongs to inner class. Yes or no? Na? So control will go to inner class. In inner class, A not there. Right? When A not there, the inner class belongs to outer class. The control will go to outer class. In outer class also, A memory not there. Yes or no? Na? A memory not there. So error. For you, A access not there. Understood this point now? You cannot go to this object. Not possible. For you, access not there. So because of this reason, very important rule also, the instance method of static member inner classes will have behavior like static method, can access only static variables of outer class directly, but cannot access instance variables. The theory. So here we can keep one cross mark. B it can access, no. So the control will come here. If it is not available, the control will go here. If not available, control will come here. Because inner class belongs to outer class, no. So answer will come. So for you, B access available. Hope you understood M2 access. Right, okay. Now, this is completed. Now I am calling one more method. What is the method now? Subclass 1 dot, subclass 2 dot, M22. I am calling a static method. So M22 belongs to subclass 2. Subclass 2 belongs to subclass 1 dot, subclass 2 dot, M22. Now we are calling the method now. We are calling the method from class directly now. Sub M22 belongs to subclass 2. Subclass 2 belongs to subclass 1. We are calling the method directly. Now M22 method will come out from the class directly. So the method came from the class directly. Now it want to access A and B. A is equal to 10 and B is equal to 20. So A access not there for you. For you, A access not there because you are coming from the class directly. Control will go here. If it is not available, control will come to outer class. A variable not there, no, but you can access B. All of you understood M22? Easy only. Anyway, this is all of you understood the diagram? Yes or no? Na? So the major concept here is static member in our class will get the memory within the outer class while outer class loading. That's the concept. So whenever you want to cross check, you can see the diagram where outer class where it is loaded, inside that inner class is available. So this diagram represents static member inner class. Right. After this diagram, make a statement. What you observed here, note. Static member inner classes. Static member inner classes will get the memory within the outer class while outer class loading. Why means static members has to get the memory within the class while class loading. So static member inner classes will get the memory within the outer class while outer class loading. Static member inner classes will get the memory within the outer class while outer class loading. All of you can remember static member inner class. Yes or no? Na? Right. Now, these non-static member inner classes, anyway, see there, the nodes. This diagram I'll paste there anyway. Non-static member inner classes. The member inner classes which are declared without static keyword are known as non-static member inner classes. These non-static member inner classes are categorized into two types: instance member inner classes and local member inner classes. Instance member inner class means outside the method. Local member inner class means inside the method. Yesterday we concentrated on instance member inner class. The non-static member inner classes which are declared outside the method of outer class are known as instance. Let me represent. Here new syntax available, no? Right. Okay. Let me go forward now. Sir, I want the flow. Execution flow of instance member inner class. Execution flow of instance member inner class. Same class files. Same class files. Subclass 1 dot class file. Subclass 1 $1. Sorry, dollar subclass 2 dot class file. And here demo inner class 2 dot class file. This is one main class. You had it. Right. You have to observe this bit carefully because instance member. Right. Look here. Now, same type of drawing, small change. Method area where classes are loaded. Heap area where objects are created. Java stack area where methods are executed. Now the first method loaded here is main. So second program, application 2. See there. M1. One method. The same type of representation. Here the class is instance. Anyway, now look here. Main class, main method. This much of clearly we draw the diagram, but only few students will remember. Remaining all will forget. Yes or no? Why means spring will come after almost 1 month. Core Java will be forgotten. But these all models are used in web services. Web services, security. When they will come, sir, on that day I'll forget it, sir. On that day, if you open your core Java, what happened now? The book looks, whether I written or somebody written, I will think it. After 1 month almost. But these two models are very, very, very important. One is static member inner class. One is instance member inner class. See there, one different diagram will be there for instance. Subclass 1, OB1 is equal to new subclass 1. Now, new means object must be created. Anyway. Right. One object must be created. 0x11. One object is created. Now subclass 1 must be loaded now. So subclass 1 is loaded. Subclass 1 is loaded. Subclass 1 is loaded. Now this is one outer class. This is outer class. Now any static members available in the outer class, it has to get the memory. Okay, right. Now, A, non-static, no memory. B, static, memory available. Now, M1, non-static, memory not available. Now, the class is static or non-static? Non-static, no. So, non-static means memory not there. So, memory not given inside this class. So, here, no memory, subclass 2. You are one inner class dollar. For you also, memory not available in this class. Because here, memory available, no. Here, memory available in the outer class or not now? Here, memory not available. You wait it. Memory not there for you. Because you are a instance. Instance will not get the memory within the class. Instance will get the memory within the object. That is the rules. Now, object creation started. Now, object creation started. While object creation started now, what are the instance members available there? They have to get the memory. What are instance now? Sir, A is instance. A has to get the memory. A has to get the memory. A is getting the memory. M1 has to get the memory. Void M1 has to get the memory. M1 got the memory. Now, the class is also non-static only, no. Now that non-static has to get the memory. Subclass 2 has to get the memory within the object. Now execution control will say, no, we will not give the memory within the object. Rules. Class means you must get the memory in the method area. Yes or no? That is a rule of your JVM. How can you load into one object? Not possible. So what they will do internally, whenever it is a non-static member inner class is there, what they will do is, they will take one indication here. One indication. Indication meaning is, the class will be loaded here only. The class will be loaded into method area only. Dollar. The class will be loaded here only. Dollar subclass 2 loaded here. But it is indicated here. The class belongs to object. One indication. Class belongs to object. The number given like this. This is 3. This also 3. Same. The class loaded there, but indicated through object. Why means according to JVM, class must be available on the method area. But here, it is an instance member in our class. So through object, we have a indication saying that the class belongs to this object. That's the indication. All of you got this point? Right. Okay. Now, what are the static members available in the subclass 2? They have to get the memory. So what is available in the subclass 2? M2, M22. So M2, no memory for you. M2, no memory. M22 for your memory. Void M22 for your memory. All of you understood this? Right. Okay. After this one now, this address as usual, the address will be loaded onto OB1. This is your outer class object. That's the outer class object. Outer class object is holding a memory, M1 memory, and memory of subclass 2. Means what? Indication available here. That's the meaning. All of you got this? Right. Now, after this one, the same like above program, we are accessing the method from outer class. OB1.M1. Same. I am calling one M1 method. The M1 method will come for execution. M1 method can access the variable from inner class, object and class. Now here. A is equal to 10 and B is equal to 20. M1 no need to explain, no, already it can access. Now, we are calling the method. Sorry, not method, creating object. Okay, right. See how we are creating object now. What is the syntax now here? Subclass 1 dot subclass 2 OB2 is equal to OB1 dot new subclass 2. Subclass 1 dot subclass 2 OB2 is equal to OB1 dot new subclass 2. What is the meaning of this is? Create object for subclass 2 which belongs to subclass, create object for subclass 2 which belongs to OB1. That's the meaning. Now the control will go to OB1. Control will go to OB1 and find the reference of subclass 2 and starts creating object. Zero x22. Now object creation starts. Look here. Subclass 2 belongs to outer class. Don't write it. Outer class object. Outer class object OB1. Yes or no now? Right. So what happened now? Object of inner class, object of subclass 2 belongs to outer class object. outer class object. Yes or no now? See there. Subclass 2 belongs to outer class object. When the subclass 2 belongs to outer class object, then subclass 2 object is there, no? Right? Object of subclass 2 belongs to outer class object. Yes or no na? Louder. Like an English question only, right? They'll ask in one competitive exam, no, like this, I think. A belongs to A, B belongs to C. What is A to B? They'll ask it. All have understood this statement, what I typed? Right. See there, I'll repeat it. Subclass 2 means the class belongs to outer class object. Anyway, when the class belongs to outer class object also belongs to outer class object only, no? Okay. Now OB2 belongs to OB1. Simply you can say OB2 belongs to OB1. Yes or no na? Right. When OB2 belongs to OB1, then members of OB1, sorry, members of OB2 must access. Must means can access the members of OB1. Yes or no na? When OB2 belongs to OB1, members of OB2 can access OB1. Yes or no na? When the members of OB2 can access members of OB1, then what happened now? OB2 must hold reference of OB1. Yes or no na? OB2 must hold reference of OB1. Can we accept this? References, yes or no na? Right. Okay. See that. That only happens. That only happens. The algorithm, that only. The written API programmer written algorithm. Whenever it finds OB1 dot new subclass, execution engine will see that and activates one algorithm. Algorithm, you run it. The algorithm says that we are referring one class from OB1. The class object will come. The object belongs to OB1. Means OB2 belongs to OB1. So when the OB2 belongs to OB1, the members of OB2 should access OB1. So internally, the address should be binded. That's the concept. Internally, the address must be binded. Internally, automatically, the address is binded here, 0x11. All of you understood this? So inner class object will hold reference of outer class object. That is a concept. Understood or not understood? Yes or no na? That only. The address binded here, no? That's the point. So outer class object binded to inner class object. Sir, who binded? Automatically. Why they binded automatically? Because they have to give access. Why they have to give the access? Because the object belongs to this object. Why that object belongs to this object? Because the class belongs to this object. That's the concept. After this line, then instance member will come. If you don't answer these rules, your web service trainer will scold core Java trainer. Of course, we are getting scoldings. That is a different issue. It's a concept. Now, this address. Now, this is the inner class object holding reference of outer class object. This address available on OB2. This is the concept. All of you understood this? Right. Class belongs to OB1. Then the class object must belongs to OB1. That only concept. When OB2 belongs to OB1, members of OB2 should access members of OB1. Direct access not possible until you bind the address. So internally, the algorithms will be binding. Understood this point now? Right. Okay. Two engineers are there. One engineer is service engineer. We people. Somebody will release the product. We learn the product. We work it. Some engineers will be creating products. Two engineers, vendor engineers, service engineers, both are there. Somebody will, we are waiting for the next product. No, sir, when the JDK 20 will come, sir. So one engineer is writing, no. He is also Java developer only. He is a product developer. Sir, how can I go to product-based companies? The student will ask. The knowledge should be high, no. Product-based company. Fresher cannot enter into product-based company. Means direct R&D not possible. Of course, product-based company you are entering also as a service engineer is the entry point. Why means here, this kind of algorithms will be written by your Java developer. This binding happens automatically. This is the link. Now let us see whether the link is available or not. Now I am calling the method. See there. I am calling the method. OB2. OB2.m2. I am calling. I am calling the method. While I am drawing only, observe it. And after drawing, I will not understand my diagram only. That many lines I am overlapping and coming. Okay, right. So I am calling M2. M2 is coming out. Number 9. Now M2. M2 accessing A and B. M2 accessing A and B. A is equal to 10 and B is equal to 20. See there in the diagram. A belongs to outer class object. B belongs to outer class. M2 belongs to inner class object. But access available now. See there how it access available. The execution control to access A, the control will come to this object. When it comes to this object, in this object, A memory not there. When the A memory not there, all of understood now. Now this object belongs to another object. Understood this point or not now? How I can know that here one address is there? If it is not available in this object, object belongs to another object. I mean the memories, no, they are short memories. Two memories are linked internally. The only concept. Now when the A is not available here, go and search in 0x11 because this memory belongs to that memory. If in this memory A is not there, go and check in that memory 0x11. Okay, I'll come to 0x11. A is available now. So answer will come. Understood this? Right. Now, I want to access B now. Same the control will come here. Not available. Take this address location and come here. Not available. If it is not available, this object came from the outer class or not now? Go to outer class. Outer class B is there? No. Access. All of you understood? That is the proof to say that in instance member inner classes, inner class object will hold reference of outer class object. In this process, members of inner class object can access members of outer class object directly. Right. All of it take long breath. These two diagrams and two syntaxes are important. Total inner class 2 only. Major models 2. Right. Of course. If I call a method I'm calling from class no. So subclass 1 dot subclass 2 dot OB, sorry, M22. I'm calling the method from the class. You know this concept already. M22 coming from. Void M22 A is equal to 10, B is equal to 20. For you, A access not there because you are a static, A access not there because the method is coming from the class. If it is not available here, goes to outer class, A not available, error. You can understand that M22 easily. Right. All of you understood this model and right. Okay. So destroy it. This is the model. What is the difference between these two diagrams now? Sir, there inner class got the memory within the outer class. Here, inner class, outer class separate, but inner class object holding the reference of outer class object. These two diagrams, if possible, take good color printout and pin it and keep it. Whenever you are attending Spring or web services, your trainer will use a term known as inner class. I am using inner class, he says. Then you can ask him what type of inner class. You can ask it. Or he only will say what type of inner class. Then see my model, rule is available. Whenever he is teaching it, you can apply that. You'll get an answer. Understood now? Right. Okay. I am commenting here. Instance member, inner classes. This is instance member, inner class. Now write. Note, NOT note. In instance member inner classes, inner class object will hold the reference of outer class object. In instance member inner classes, inner class object will hold the reference of outer class object, comma. In this process, the members of inner class object can access all the members of outer class object directly. Access. So the two models we demonstrated yesterday. Now, non-static member inner classes, how many types now? Two types. Instance member inner classes and local member inner classes. Now make a siding local member inner classes. Local means inside the method, no? The non-static member inner classes which are declared inside the method of outer class. The non-static member inner classes which are declared inside the method of outer class are known as local member inner classes. The non-static member inner classes which are declared inside the method of outer class are known as local member inner classes. These local member inner classes can be declared inside static and non-static, nothing but static and instance methods of outer class. These local member inner classes can be declared inside static and instance methods of outer class, both. You can declare inside the static method, you can declare inside the instance methods. Both are allowed. Right. Look here. Now I'm taking, see there? Inner classes, application 3. Package test. Package MAccess. Right. Under test, I am taking one class again. Subclass 1 I am taking. Outer class name I am taking same always. Outer class. Look here. So public void m1 of int x. I'll take one. Outer class instance method. So public static void M2 of int y. This is outer class static method. So one is instance method, one is static method. Inside the instance method, I am writing one class subclass 2. I am writing. Here also I am writing class subclass 2. I can declare one class inside the class. So this is local member inner class. This is local means inside the method. So now some people will think it, sir, what is this headache writing class inside the class? Why, sir, this are actually for protection. Example, if we take one password in Java, 52 layers of inner classes will be there. 52 layers means one inner class, one class, 52 will be there. Inside that, there will be password. 2 classes only, double headache coming. If I want to draw 52 classes on a paper, I must keep biggest chart, I think. This room full, I must keep chart and I must draw. Not possible. Human brain will be blasted. But in the protection layer, that only. 2 modules are there for you. Spring security, web service security, providing protection for your data. Already you know, cyber crimes are very high. But our application is running in the internet world now. So definitely one stage crossed for application, security will be there. In the starting level, you are not trying, but one end level will be there, no security level. When the security level comes, definitely our language has to provide the model. He says, if you want to protect it, you write the class inside the method also. Somebody will not understand it. Understand? I'm writing one class inside or not now, right? So inside that class, again, method will be there. If you write one class inside that method, we'll understand it. So he given a possibility. The language provided possibility. You can write one class inside the class. You can write one class inside the method also. Sir, which method? You can write in the static method. You can write in the instance method. If I write one class inside the instance method, the behavior is instance member inner class behavior. The class behavior like instance member inner class. Diagram number 2 is there now. This behavior only. Whenever you write one local inner class inside the instance method, the behavior is instance member inner class behavior. Whenever you write one static inner class in static, the behavior is static member inner class behavior. All of understood this? Right. Okay. Make it. Continuation you write. Local inner class in instance method will have behavior like instance member inner class. Will have behavior like instance member inner class. Local inner class in static method will have behavior like static member inner class. Local inner class in static method will have behavior like a static member inner class. Local inner class in instance method will have behavior like instance member inner class. So altogether two models only. One is static, one is instance. Because the two diagrams are crucial. Coding rules. Local inner class. Local inner class objects are local inner class objects are created inside the methods. Coding rule. Local inner class objects are created inside the methods. So wherever the class is declared, there only object created. That's the meaning of it. Local inner class objects are created inside the methods. Wherever the classes are declared. The concept. See there, for demo purpose. Here I'll write one method. So public void m2 of int x. Now system dot out dot println I'm displaying. Local inner class m2. Now the system dot out dot println the value x is equal to plus x here. So public void m22 I will take it int y here. System dot out dot println local inner class m22 of y. Println the value y is equal to plus y. Just for demo purpose, I'm taking one method here. What is the rule of inner class now? This local inner class is very popular. I'll show the application also. Application means where to use it, I'll show. Right. For that model is there. Now here, create object there only. Subclass to OB2 equal to new subclass 2 object here only. Local inner class object. Local inner class object here only. Anyway, object is inside the method, no? Call the method ob2 dot m2 of x. We are calling the method also. Anyway, object is here only, call the method. Now, same way, here we are creating object. Subclass 22 ob22 is equal to new subclass 22 is also local inner class object. Local inner class object. Here ob22 dot m22 of y. Anyway, you can declare one inner class inside the method. We call it as local inner class. The local inner class objects are inside the method only. That's the rule. Whenever we declare one local inner class inside instance method, The local inner class is instance member inner class. If I declare one local inner class inside the static method, that is static member inner class. That's the concept. If I run it, I'll get the answer. Which answer is coming? Main method class not there, no? Old program answer is coming. Right, go for main class. Demo inner class 3. Import test dot star. Create object for outer class. Subclass 1 OB1 equal to new subclass 1. This is outer class object. Now OB1 dot M1. This is outer class instance method call. Now, whenever you want to call a static method, subclass 1 dot M2. M2 to M2. I took M2 na. Okay, M2 I took it. M2 12. So this is outer class static method. Outer class static method call. We had it. Now, if I run it, now I'll get the answer. Coming now, local. So finally, you can declare one class inside the class as a member. You can declare one class inside the method as a local. These are the two models available to you up to now. Here, subclass 1 dot Java demo anonymous inner class demo inner class 3 dot Java the main class. So read this concept. Anyway, yesterday you understood the concept, but I presented in the diagrammatical form. Watch it and come once again. So tomorrow I'll make a review on local member inner class, and tomorrow we go for anonymous classes without name. There the assignment will be started. The point. Okay. Take a break for today. Right. I'll upload the notes. Yesterday's notes updated or not updated? Not updated. Okay.